Hello. Okay, I hope you can hear me, guys. Well, it's a small audience. It's going to be like a private session, but in a way that's better. So what I'm going to talk to you today is actually something that is quite underestimated and mostly overlooked during the development of a project. And it's actually about your documentation. And if you think about it, the documentation is actually the central point of your whole project management. If it could be like people coming and going, but the documentation is the single source of truth. So it's quite important to keep it consistent, to have it rendered nicely into different formats. It could be to be rendered flexible, etc. So I'm going to tell you a little bit how we have documented our product and what tools we have used to document our product. What tricks we have used to do it. So I hope you enjoy it. Here's a slide about me, a little bit about myself. My name is Petar, I'm from Bulgaria, and I'm a contributor to the Apache Software Foundation, where I'm part of the Apache Maven development team. I wrote a book, like 7 years ago. I wrote a book when I was 25. And here's some of the companies that I've worked for. Before I begin, I'd like to really tell you more about the product that we're doing in our company in order to really understand what the problems we have, what kind of problems we have, and then, of course, the solution. Because if you don't have this context of what the product is, you're not really going to be able to grasp the whole idea of what are really the things that I'm telling you here. So, like I said, I work for a company called Nemesis Software. And Nemesis Software is building what we're trying to say is actually an application development framework. So it's a framework that you can use to work very quickly construct very complex solutions, web applications. And the whole project is designed to be composed out of several different projects, right? So we have something that we call a BOM at the very top. How many of you know what a BOM really is? Okay. Yeah, it's a Maven BOM, yeah. It's a Maven BOM. Okay, I see a couple of hands, that's nice. It's a Maven BOM, it's a POM XML file that declares all the dependency management section, all the project properties, all the dependency version properties, etc. And it pretty much stands in our product as a top-level project, which is actually apparent for all the other projects, sub-projects. Then underneath we have a platform. The platform has one module called Core. Now the Core contains all the functionality that is common for every web application. Now you can imagine every web application needs session management, security, login, logout, permissions, user groups. No matter what kind of web application, this is always the case. So this goes all into the Core, and then we have modules. We have modules which are Maven modules, but we call also our platform has modules. These are more than 120 modules. So you can imagine we have a vast majority of modules. We have a marketplace with a lot of modules. Of course, Maven plugin, etc. Then parallel to it, we have an archetype, Maven archetype, that you can use to construct very easily sample stores. Let's say you want an e-commerce website, so you can construct an e-commerce, B2C, B2B e-commerce. You can construct a logistics website or insurance, banking website, etc. We also have administrative interface, which we call a console, that allows you to administer the application that you build, and of course an Android applications. Now, these are the core components of the product itself, and they all have the parent, the BOM. So the BOM defines all the project structure, how it's going to be built, and all these guys are just following it. There are a couple of other projects here. You see blue. They're marked with blue because they don't really extend from the BOM. So we have a Nemesis JUnit listener, which I'm going to present to you a little bit more further on in the presentation. And we have a Nemesis Maven skin, which really defines how the documentation look and feel will be presented. So just remember this picture. Everybody just extends from the BOM, and the BOM defines everything on a top level. Then this is technology stack. It's pretty standard. We're using Java, Spring, Docker, Cloud Foundry, Maven, Redis, etc. And this is what a typical application really looks like. well, you have the core at the very center, like I said, and the core is composed of all the common functionality that every website needs. Then you have functionality modules. Half of the modules, all those 120 modules I told you about, half of those are functionality modules. So you can add them and you get a new functionality. So you add the shopping cart functionality and you get a shopping cart on your website. You add search and you get search. The other half is like industry-specific modules. So you can get insurance module and it will give you like APIs to build an insurance website. You have different channels and these channels request your application and you have different services that are already installed. Right? And once you add all those modules to the class path, you end up with an application, and each of these applications has a repository and a facade. These are two layers exposing their REST services. The repositories are Spring Data repositories exposed via REST, and the facade is a standard business logic facade that exposes business logic. Just another presentation of how it looks like. It's a standard 3-level application, the end result. So now, what is the challenge of when you want to document this kind of application? Well, documenting this kind of application is you could approach with several ways. You could probably use a wiki, which is one way to approach it. You could probably use some sort of other tools. You could store static HTML files somewhere, or other options. But it's not really hard if you want to document this website, this application. What's really hard is to document this one that has 120 modules. They're all diverse. They all reside in a single build system. And this is where the challenges come. So we have, like I said, we have 120 different modules. We wanted, when we started documenting it, we said we want the documentation to be part of the source code. What does that really mean is that you want to keep it right next to the source code. You want to keep it in GitHub or in a version control system so you can follow the changes, and as soon as a change is introduced in the code, you actually apply the change in the documentation as well. Or, you know, best case scenario, you don't need to apply it, it's already applied there. So you want to keep a version history of the documentation as well. It's not just write once and then forget. We also want it to be the documenting process to be part of the build lifecycle. So as soon as you build the project, the documentation always happens. Either it be Jenkins or some other continuous integration tool to actually document the whole process. And if it fails at some point, we wanted the documenting process to fail as well. Well, you can imagine when you have 120 modules, you might as well want to actually document, be able to document a single module, not just always run the whole process. And last but not least, we want to be able to produce several different formats. So write in a single in a single format, but out of that produce several different formats such as PDF, it could be a docbook, etc. You know, having these bullet points at the beginning, this is the setup that we came up with. So this is a developer. They write their documentation, like I said, in the source code repository. They push to Git, then Jenkins detects some changes. And Jenkins triggers a Maven build, which actually performs the whole magic behind it, using the Asciidoctor Maven plugin and the Wagon SSH to deploy to a website called docs.nemesis.io. There we have 2 folders, current and current snapshot, and those are symbolic links that follow, it's Linux symbolic links that actually point to the release that is currently being built. 1.5.2 release and 1.5.3 snapshot. Like having this website right now, having this setup right now allows you to actually trigger it. As you can see, I can trigger it from the development machine with Maven and build a single module or build a whole thing with Maven, but I don't need to push it and have Jenkins detect that and perform the whole thing. Of course, it will happen once I push, but I'm able to build it, deploy it much quicker, much faster, and just see the results in front of my face immediately, like I say. Right? the whole setup is pretty standard. We're using Maven, and the documentation is being written as the Maven as site, a Maven site. We're using the Maven site plugin, and then there's an Asciidoctor extension to the Maven site plugin that you can use to render Asciidoctor. Then this is being pushed, like I said, with through SSH using Wagon SSH, the extension. So a few words about Maven. Let me show you my. Okay, a few words about Maven. I will show you my setup. So, like I said, we're using the Maven site plugin. Okay, here's my setup. You can see. Oh, do you guys see it? It's. Is it better now? Okay. So we have the Maven site plugin. The property defines the version, of course, and it's a pretty standard declaration apart from actually this configuration here. It actually says this is the configuration where the Asciidoctor configuration happens, and of course we have this dependency added as well. So this dependency adds the Asciidoctor Maven plugin, which is actually an extension of the Maven site plugin and allows you to render Asciidoctor. How many of you are familiar with Asciidoctor and Asciidoc syntax? Oh, a couple of guys, that's fine. So, next to that we also have the Asciidoctor J diagram, which allows you to render, okay, I think you can make it even bigger. Yeah, the Asciidoctor J diagram, which allows you to render different diagrams from text and make it into a picture. I'm going to show you a bit about that later. We have the Wagon SSH, like I said, because we need to deploy to the server, to docs.nemesis.io, to the server, and that's pretty much it. This is pretty standard. The configuration about these Asciidoc is again pretty standard. What we are saying is that we're requiring the diagram and the base64 and the time modules of the Asciidoctor, and we're saying that we want to provide to create a book. These are some of the additional attributes where I want my images to be rendered, where the folder is, with language, etc. Okay, custom Maven. Okay, yeah. Well, now that we have this, we are ready to actually start writing our documentation and rendering it. Well, unfortunately, that's going to render with the default Maven skin. So if you guys want to create your own skin, well, remember I have here a separate project called Nemesis Maven Skin. So the Nemesis Maven Skin is over here, and I'm going to quickly show it to you. So the Nemesis Maven Skin is just a standard Maven project. Inside of it, we have this SRC main resources folder for all the resources. JavaScript, images, fonts, CSS, etc. But inside the meta-inf, we have this site VM, which is a velocity macro. And the site VM allows you to specify how exactly you want to have the HTML structured for your website. In my case, well, I have a couple of macros here at the top. And then somewhere here, it starts with the body, and I have defined my site navigation on the left. Then I have defined icon navbars and then some top levels, etc. The CSS, of course, like I said, the CSS resides here in the resources as well with the JavaScript and the images. And then once I have this built, it produces a jar file, and this jar file could be used inside every one of my projects. Every one of my projects has this src site folder with a site XML, which is the site descriptor, and then I can specify what's the skin. So I can specify what's the skin, and once I change the skin, I can rebuild the HTML, JavaScript, and everything, pack it inside into a jar, and then specify the new version here. Okay, so this is pretty much everything you actually need to know about the Maven setup. Maven actually allows you to render different kinds of input sources. So I chose Asciidoctor because it's pretty new and it's pretty easy and intuitive to write, but it actually allows you to render also markup other markup languages such as Markdown, FML, FOP, I think. And all of these guys, if you want to render them, what you need to do is you need to provide the type of your source into src site folder, just like I have done here. Into src site, I have Asciidoctor, which is the type, and then the name of the project, the name of the article. And here's my article names. Now, here's something pretty important that you need to understand is half of these, you can see half of these guys are called index.adoc. They're written in pure Asciidoc. The other half of these guys is like release.adoc VM, are written in Asciidoc, but they have the VM extension. So you can see from the diagram here that the VM extension first goes through a velocity transformation and then is being given to Maven to pass it. So if it doesn't have the VM extension, it goes straight directly to the Doxia sync API, and after the Doxia sync API, it combines it with the skin that you have chosen, the site VM of the template of the skin, and the final skinned XHTML is rendered. But of course, you can add a velocity markup and mix it into your documentation, and then you have to name your articles.vm. So, well, this is something really powerful. It doesn't look like much, but it's something really powerful. Like, imagine if you have velocity, if you can use velocity, then you have, of course, if statements, you have for loops, you have like tons of cool and neat features. Right. So, Asciidoctor is actually an open source implementation of the Asciidoc in Ruby. This is what it says on their website, and Asciidoc itself is a new markup language that you can use to write your documentation. It's much more intuitive and much more powerful than Markdown, FML, and APT, which was up to now supported with Maven. And people often say, why do we need another markup language? But well, we need it because, like I said, its simplicity, its beauty is it can be compared with Markdown and APT. So this is, in fact, what Asciidoctor is. I'm not going to follow really how to write Asciidoc. They have a really nice documentation written in Asciidoc, of course. So I'm going to move to some examples of how we have used it. Well, like I said, if you want to use it, add the Asciidoc Maven plugin to your site plugin declaration. Use the Asciidoc diagram if you want to render images from text. And configure it, add some configurations like I have done. And then you start writing, you put your Asciidoc files in src site Asciidoc. And just run Maven clean site or Maven site, which will take everything that's in src site. It will create a site for you using the default skin or the skin that you have provided. And this is another time. This is the most important part of the presentation. Half of the files can be pure Asciidoc, and the other half could be. Done? Oh, good. Sorry about that. Technical difficulties. Well, it allows you to, right. it allows you to also include source code snippets. What does that mean is that you can reference, in your documentation, you can reference your source code. So when the source code changes, the documentation doesn't need to be updated. It updates itself. I'm going to show you that later. It allows you to include diagrams, so you can write text and produce images with data, for example. It allows you to include raw HTML and JavaScript. So being able to include raw HTML and JavaScript, you can do pretty much anything. Well, and of course, if you have velocity, then you have for loops, you have if statements, so it becomes really, really powerful. Right, so here's some of the snippets that I wrote. And you guys probably gonna find it interesting. So module and search lister. Now, here's how our documentation pretty much looks like. You go to docs nemesis.io and you have this this thing on the side, and you have now you're stepping into the BOM, the top level one, and now it tells you all the sub projects. You can go into platform, you can go into the modules, into the Maven plugin, the sample store, etc. You have them listed also on the side. But here's something I wanted to have, like the module search lister. The module search list is when you go to the modules. I said I have 120 modules, so it's going to be hard for companies to and other people to find the correct module easy. So I wanted to have something like this. It's kind of like a search, and you type in something like cache, and it finds all modules related to cache. Or you can type in Elasticsearch, and then it finds Elastic and pre-selects them. Well, how do we do this? It's well. It's kind of easy. So first things first, you go to the you go to the platform because this one resides into the platform, and then underneath it we have the modules. You go into the platform, you go into the modules. Of course, we have src site, Asciidoc, and this is the index HTML of the Asciidoc. In Asciidoc, if you type 4 times plus symbol, and then another 4 times plus symbol, everything that's in between is actually treated as raw HTML. So you can put divs, spans, whatever you name it. It's whatever you like. So this is pretty much a raw HTML snippet inside the documentation. So I write the documentation on the top, and then I have the raw HTML here at the bottom. And of course, because like I said, it's because it ends in .vm. If you remember here from the presentation, because it ends in VM, it's going to be first given to velocity, transformed into something that Tahchiev parser can pass, and then move forward down the sink and finally produce the XHTML. So this one is .vm, so I can put inside velocity macros. So what I'm going to do is I can say, you know, from the session get all the projects, and for each project, this is like Maven projects. So from every project, find all the modules, all the submodules, and you know, make a loop, and find and print the name of the module. And this is the project. These are all the modules. So it's going to you guys see it. So it's going to loop through each of these modules, and it's going to print. It's going to print. It's actually going to substring this from the start of the prefix, and it's going to use it. If you understand velocity a lot, it's going to make it to lowercase, and it's going to join with a space. So I can search not just by the name, but also by the folder in which the module resides. So it's kind of standard. It's kind of nice. Further down, I wanted to have another snippet. Oops, which one is it? Yeah, the list of dependencies. The list of dependencies. Okay, I think I have here into the payment. I have to go into the payment. Let's see, which one is it? I go this one. So the payment modules. You can see when you go into the payment modules, it kind of lists this nice grid and shows you all the sub-modules of the current module. And this, how do we do this? Well, you go to the modules, you go into payments, again, src site Asciidoc. There it is. So it says pick a module, and again, find all the projects in the session, iterate over the modules, and then if the project URL starts with this one, because it might have some others from other projects, then literally print it. Next one would be you want to have a list of dependencies. So when the and this is all dynamic. You know, once you change the POM XML, the documentation is reflected. You don't have to update it. So this nice little grid that I wrote here is actually again another snippet section. So a list of dependencies. How it is done? Well, there it is. It's this snippet here. This slash and then 3 equals, this is an Asciidoctor markup to make a grid. And then inside of the grid, inside of the table, again we do for each, and from the project we can get the dependencies and display the group ID, the artifact, the version, the type, and the scope, which renders pretty nicely. So every time we add a new dependency or remove a new dependency, this is reflected. We don't have to update the documentation. Final thing, well, for some of the guys during development, it might be useful to have the actual POM XML. And like I told you, we have the option to include it into the documentation. So how it is done, well, we can say include. Again, this is Asciidoc syntax, include, and then we can say find the base year of the project and then include the POM XML. The empty brackets here are some option that we can include. Asciidoc allows us to include just a snippet of the actual POM XML, not the whole one. Well, I've decided to include here the whole one, so here it is, just as a reference. Furthermore, what's here? Well, we have breadcrumbs and navigation. Well, if you go inside one of these modules, or, well, you don't have to go into the modules. You can see the breadcrumbs here at the top, like home, platform module, payment modules, etc. How is this done? Because it's dynamic. Again, remember, nothing is hard-coded here. Everything is dynamic. So how it is done, it's you go to the skin. This way, you go into the skin, open the skin descriptor. So it's in src main resources Maven. Open it. And then you can see I have the breadcrumbs defined here. And of course also the main menu on the left. And the breadcrumbs as well. The breadcrumbs are, this is how they're rendered. They're rendered inside the div that you saw on the top. How they're defined. Well, they're defined inside the src site, the site descriptor. So you can say, oops, let me zoom for you. So you can say I have home and platform, and everything apart from that, home and platform are always there. These are the breadcrumbs that I have that I want always to be there. Everything else is just rendered by Maven. Maven provides extra breadcrumbs based on the name of the submodule of the POM XML and based on the current URL that you're browsing. Okay, next one. Well, the navigation is pretty similar. The navigation is here at the bottom. I want to have always a reference to the parent Maven project, and this is what it says. Well, it's a reference menu to the parent, so you have it here. So I can drill down further down, and I can go back up following this pattern, and then I actually end up at the BOM, at the very bottom. And how it is rendered is defined in the site XML descriptor of the site VM descriptor of the skin. How actually it is configured is configured here inside. The menu is configured inside the site XML descriptor of the project. Modules again defines submodules of the current module, and the other menu items are pretty much standalone hard-coded from me. So this is it about breadcrumbs and navigation. Well, again, what we're building here is Spring Boot application. So being a Spring Boot application, you have extra features such as you know, the application property files with their descriptions and their JavaDoc comments, etc. So I'm going to show you a bit about a few widgets that we have written on the Asciidoc and Maven, around Asciidoc and Maven. Well, to tackle these Spring Boot features and how to present them nicely. Our setup, we have one abstract JUnit Spring context test. Well, this comes from Spring again. Well, then we have the abstract platform REST integration test. Because if you remember correctly, all those 120 modules that we have, all of them expose some REST API. And when they expose some REST API, that REST API needs to be tested. So each module defines its own abstract platform core, base integration test, that's for the platform core, a voucher module integration test, the CMS module integration test, etc. And they all extend from this platform REST integration test, which defines the common logic around testing the REST API. So if you look into, well, that's pretty much it, abstract platform REST integration test. The abstract platform REST integration test defines the mock MVC, it auto-wires some extra repositories, some REST documentation, and constructs in the setup method, constructs how actually the mock MVC should perform. How many of you guys are familiar with mock MVC? Okay. Okay, that's a good number. Well, mock MVC is a way to test your REST APIs, and not just REST APIs, but every web API that you have. So you can say mock MVC, perform a put request or a post request with these parameters, and then expect that the result is, I don't know, success or not found, etc. So mock MVC is configured this way here, and using Spring RESTDocs, I'm able to configure the documentation configuration. So instead of just making a REST call and saying make a GET request with these parameters and expect that the result is 200, you could actually document this code, and you can say whenever a request is made with these parameters, as an example, the response is 200. So mock MVC, I configure mock MVC here, and then I have all these for every module, I have all these base integration tests for every module. Okay, so Spring Boot properties lister. The Spring Boot properties lister resides, I'm going to show you, it goes into the modules, you can find the rest. Okay, here's some properties from Spring Boot. And again, I want to document them. I want to document what kind of a type they have, what kind of a description they have, etc. And how do I do that? Well, you know, as a Spring Boot application, Spring Boot provides these meta information for you if you go into, well, modules, REST services, and then target. Okay, classes, meta-inf. Yeah, so Spring Boot encapsulates, it takes all the properties from the object and extracts them into something called Spring Configuration Metadata JSON. So if you open it, it kind of looks like this. Then this meta information is included into the jar file, and it gives hints to IDEs so that you can do autocomplete and different kinds of stuff. So my properties, for example, my Spring Boot properties are here. I have, you know, different properties inside, and during compilation, Spring will create this meta information for me. So what I can do now is I can go into SRC's site, Asciidoc, and here's my snippet that renders the table. Well, this table actually. So this snippet actually uses file utils and says if this Spring configuration metadata JSON file exists, then you can read a JSON object out of it, you can parse the JSON object, and then you start making a table, and then for every property in the JSON, you iterate and display pretty much it. So it's a nice feature because once you change this file, it automatically reflects into the documentation. You don't have to do anything extra, and this kind of documentation is self-maintained. Right. Next one is the REST tester. Well, I wanted to, when I started with all this Asciidoctor and everything, it kind of like came from the idea that I wanted to have people that want to use my REST API, you know, provide them with some documentation which is kind of easy and understandable for them. So I had this idea in my mind because, you know, usually people come and say, how can I list all the products, for example? And I wanted to give them a widget. I had a visual vision in my mind. I wanted to give them something like this. And I could say, go to the cart, and then you could say, get one cart, and then it's going to give them like the curl command for them. And I found out this project called Spring RESTDocs that does exactly this. So you write a JUnit test with mock MVC that performs a get, and then at the same time they also document the get command. So how do I do this? Now, then my second problem was how can I do this REST tester, you know, and include it inside inside Asciidoc? Well, it's what I really thought about is that if I had some kind of a JSON file like this one, RESTDocs metadata JSON. If I had this kind of a JSON file that says, well, repository, because I have several tabs here, you can imagine I would have repository, facade, some other layer, REST layer. And then inside the repository I have different variant attributes and then the different commands that you can execute. If I had this JSON file, it's all going to be good because then I can go here and I can say, you know, read the JSON file. Here's what it is. Read this RESTDocs metadata JSON. Then again, the same thing as below. Get the JSON object, parse it, iterate over all of them, make a few radio buttons here for the different command that you want, like raw, HTTP, etc. And then you can say get all, and then it gives you another type of command. And I thought, if only I had this JSON file, then I'm all good. So now the second question is how to produce this JSON file, right? Well, this JSON file, if you look at it, it contains all of the tests that have been executed on the server. So you write a couple of mock MVC tests, and then you want for every test that is executed, for get, for put, for post, for patch, for delete, to have this JSON file created. So what I ended up doing is actually, you go to the top level, the very most top level platform REST integration test, and then I specify a JUnit rule documentation. Okay, well, this is not this one. This is actually for the Asciidoc. I specified. Let me see. I specified my own run listener. So I knew that, you know, in order to have this JSON file, I need to intercept every JUnit invocation, and I wrote a separate plugin. Let me see, in a separate project called JUnit Run Listener, which is actually a JUnit Run Listener which listens for JUnit executions. So there's a method called test run finished. Well, in the JUnit run listener, you can say you can override a method called run started, run finished, test started, etc. So what I'm really interested in is I'm only interested into the run finished method, and then I can say, okay, render whatever is in this static variable documentation, render it into this RESTDocs metadata JSON. So when all the tests are finished, render whatever is in the static variable into a JSON file. So how do we put methods, how do we put executions into this static variable? Well, we go back to the platform. And we say, when we are setting mock MVC, we can say with additional defaults, and then we say get the operation name, because every operation actually has 3 parts. So it has the repository or the facade or the different tab that is, if you look at the tabs here, there's only one at this point, but there could be more. The different invocation, then it has the name, it has the first field, and then the method name. So you split it, you get the invocation name, you split it, okay. You get the operation, you split it by the slash symbol, and if it's actually always 3, then you know you can add this element to the collection of the JUnit run listener. And this actually is executed every time a mock MVC performs something. If they perform get, okay, then they call the JSON, and I split whatever is called, for example, product, HTTP repository REST integration test. So I'm saying test get with some product, and then I say get mock MVC perform, etc. And I say document this into repository base URL get 1. So now I'm ready to split by this symbol, and I'm able to produce an array of 3 different strings, and then mock MVC RESTDocs will call this JSON method, which will add it to the static collection, and after everything is finished, the JUnit run listener will persist this to the RESTDocs metadata JSON file. That's pretty much everything that's behind it. Now I have a few more minutes. I'm going to show you where this is going to the future. Well, yeah, I think I already spoke about this. Right, so what's the future improvements that we can do in this setup? Well, as you can see, all the widgets are actually some code that you have to copy paste all across your documentation. So, for example, this one, you know, if you want to have a new table of dependencies into some other module, you have to copy these, like, 10 lines, and you have to paste them there. So it's not very intuitive, and again, this one is 20 lines, I think, so you have to take this and copy it into some other. So it would be really nice if you could extract this as velocity macros. So this is, I'm working right now with the Maven development team to have this supported and extract these as velocity macros so that you can just reference them as method names. So you can say, I want Spring Boot properties, put brackets there, and then this is going to render all the Spring Boot properties, etc. IntelliJ IDEA has some really nice support for Asciidocts. So if you open some project, then you're going to see here on the left side it's getting rendered, and you can see some preview. So once you write some changes, you can see them automatically being reflected. Unfortunately, that's not really true if you have index.a.vm. Those are treated as text files, so you don't have this, which is kind of like sucks. So I'm speaking with the IntelliJ IDEA developers to have this improved. I think it's low on the radar for them, but that's pretty much it. All those things that I'd like to improve. I hope you guys liked it. Let me know if you have any questions. I have I think 2 or 3 minutes left. Any questions? Yeah. Sorry, say again?
Did you consider it to use Spring REST Autodocs framework?
Spring REST what?
Autodocs framework. It's another framework based on Spring REST Autodocs.
I've never heard of that, sorry.
Okay. It allows you to document fields using introspection of JavaDocs under a field.
That's nice. No, well, you can show it to me later. I've never heard of that.
It reduced in your case, I'm pretty sure you hard code a field description in test, right? If you have common entities in different endpoints, it will allow you to reduce duplication dramatically. And, what was the reason to generate this JSON metadata files?
Yeah, is this one, RESTDocs metadata.
Yeah.
Because I want to parse it from Asciidoc I have this, let's see. Yeah, I have here, I'd like to parse it, and I'd like to go through the metadata file and actually create this widget. That's the whole goal. You know, I'd like to create this widget. So when I'm running the tests, I'm creating the JSON file after the tests are finished, and then when the documentation starts, it can use it as a source file, you know, to render this.
I think you could use part of Asciidoc. No, I mean in Asciidoc, you should have a table of content.
Yeah, well, if you decide to render it as a table, it gets really, really big. I have, I think, about 100, no, in this case it's 50, but the other module has 100 attributes, and then like each one has about 10 methods that you can, so it gets like about 1,000 lines of table. So this way it's much more clear, and of course you have different snippets. So for curl, for every different command, you get different snippets. So this one gives you the snippet for curl, but you can also have one for HTTP, and then one for raw JSON, and etc.
Okay. Thanks.
Anyone else? Okay. Thank you, guys.